All right, this is the Trig Lab introduction. You are going to be exploring sine and cosine graphs, and we're going to start with a circle, okay? So you should have printed this out. If you haven't, go ahead and pause the video and print this out ahead of time. What we're going to do with this circle is we're going to just simply identify the unit circle values that you've been memorizing based on the 30, 45, and 60 degree angles, the special triangles within the circle, and you're going to be marking those around the perimeter of the circle. And here is a hint for this. Obviously, this is where 0 radians are, right? And this is going to be our pi over 2. We know that this is pi. We're really just going to be, you could go all the way around the circle and do, you know, your half angles, which then would be, there we go, your halves of 2 pi. And so what I'm going to do is use these markings. If you notice, there's two fairly bold markings. This one's a third of the way up. This one's another third of the way up. So this would be your 30 degrees or your pi over 6 angle, right? This would be your 60 degree or your pi over 3 angle. And then right in between, it's not the long one, it's right in between two longer ones, that is your pi over 4 angle. Okay? At this point, please pause the video and fill these in for the rest of the circle. All right? All right. If you've done that, your circle should look something like mine. And at this point, we're going to do step 2. Step 2 is to take a length of string. I'm just using twine. This is really nice because it'll soak up your markings easily. But anything that you can mark, I'm also using a Sharpie marker because it actually sinks in and shows the markings really easily. But you could use a ballpoint pen, you know, whatever it is that you can see the markings. And what we're going to be doing is we're going to be marking our points along the circumference of the circle, okay? And another thing I have done is I've actually made a really nice clear knot at the end of my string so that I know exactly where I have started, okay? And I'm going to tape it down. That'll be another thing that will help me keep things straight here because I'm going to be wrapping this around and marking each one of these points, okay? So I'm actually going to start with marking this knot as my 0 or 2 pi point. It's going to be 2 pi when it hits the end, okay? But it's my starting point, and then I'm wrapping, okay? So here's my pi over 6. I've marked it. Pi over 4. I'm not stretching. I'm just laying it straight on top because I want it to be representative of the proportions of these angles around the unit circle. All right, so here's my first quarter. If you notice, I've marked each one, and I'm going to keep going. All right. If you're struggling to keep it wrapped around your circle appropriately, you could do some taping as well, taping down, and that might help a little bit. I might do that at my halfway point, but so far, not too bad. Okay, and I'm getting all the way around to pi. Okay, and at this point, I'm going to go ahead and tape something down because I want my values to be pretty clean. Okay, so I'm just taping it down at my pi point, and then I'm going to keep going. There's my 7 pi over 6, 5 pi over 4. Okay, just keep going until you finish, all right? Okay, so I am now back where I started, all right, and I've actually marked my ending point as well as my starting point. And if you notice, the string is marked, right, with each one of my unit circle values on there. And at this point, I'm going to remove my string. I have it taped in 2 small places, so it's not going to be hard to do that. And we're going to go on to part 2 here. Go ahead and keep your unit circle. You're going to need to refer to this again and use it for something else. Set that off to the side. Okay, part 2 is to take this template that if you were in class I went ahead and provided for you. All I've done here is I've taken 2 8.5 by 11 sheets of paper. I have taped them together, okay, to form myself a nice long, it's 8.5 by 22, right? That's one of the reasons you have about a 22-inch length of string. In order to create my x-axis, I will fold this right down the center, okay? And what this does is it gives me a nice, clean, straight line, and I'm going to go ahead and mark that with a ruler using that. Using my fold, right, as a way to make sure I'm right in the middle. And this is going to be the x-axis of your sine or cosine graph. It's going to be used for both, all right? Okay. And then you want to double check your string, all right? Okay, so this is my beginning point right here, right? And so that's going to be 0. And I'm noticing this is here the last point right here. So I've got plenty of room. I've done this properly. So I'm actually going to draw a vertical line to represent the y-axis on this side here, okay? Okay, so this here is y, and this is my x-axis, all right? And my graph is going to end up fitting along here. And so now I'm going to transfer these little black marks. I'm going to transfer them onto my x-axis because the input variable for trig functions are your radians, okay? So these will match. This is like a straightened out version of the circumference of the circle, okay? So obviously that's 0. And I'm going to just mark each one of these black marks on my graph. All right. Okay, so if you have done that, you should have a little mark where you had a black mark on your string. I'm going to put the string over to the side. And now what I'm going to do is I'm going to transfer my radian measures onto the x-axis, okay? So the first one is 0, then we go to pi over 6, right? Then we've got pi over 4, etc. Okay, so take a moment to transfer all of your values. Your last value here is going to be 2 pi, all right? All right, so this is my completed template. And this is all ready now to start putting on my sine or my cosine values. I could do it for either one. So considering that you're going to be creating both a sine and a cosine graph, what I would suggest that you do at this moment is stop the video, and if you have a printer copier at home, so you don't have to do this all over again, make a copy. What I did is I went ahead and photocopied, right? I photocopied mine, all right? And I'll just end up taping it together. It cut off my pi, so I'll just simply draw the line and put in my pi there. But now I've got the same template to do for my cosine graph, so you don't have to repeat that step, all right? Okay. All right. The next step is going to involve this piece of paper again, your unit circle. Before we can put values on there, we need to know how tall or how long our values are going to be along here. This is where I'm going to use my little right edge. This is kind of a handy way to do this. Otherwise, you're kind of guessing with this one here. Okay, remember that sine is your y values, okay, of any of these coordinates, all right? So if I take my little right angle measure, and if I drop this at the right angle onto the x-axis through my pi over 6, I'm going to go ahead and trace that so it's easy for me to see. Okay, there we go. And that is a bad pen. I'm going to try that again. Use my blue. Okay, so going down here, down to my axis at a right angle. So the distance from here to here is this length, okay? As it turns out, this is going to, since this is my y length, this is going to be my sine length, okay? And then I'm going to do The same thing here. This will be for the 45, or pi over 4. This will be for the 60, or pi over 3. Okay. Okay, so, and then this is going to be the unit right here, right? I've got this length here. So notice there's only 5 different values that sine can be as I go along the circle. Sine can be 0 if it's here, right? We know that if this is a unit of 1, then the sine here is going to be a half, right? Okay, the sine here is going to be root 2 over 2. The sine here is going to be root 3 over 2. But we're not even going to deal with the numbers because we're graphing this. So this is where I'm going to be using my spaghetti to help me with little measuring, okay? And so I'm going to take my piece of spaghetti here, okay? And I'm going to go ahead and measure it. And I'm going to show you a little trick because it's really hard to break spaghetti here. And I'm going to snap it, okay? So if you want nice little measures, this is kind of a little trick, okay? So this is going to be my unit 1, all right? This is going to be my root 3 over 2 measure here, okay? And again, what I'm going to do is I'm just going to use my protractor here, and I'm going to snap it off right there. I'm going to do the same thing with this one here. This is my pi over 4, or my root 2 over 2. And then finally, I'm going to use this one. This is just barely, it's almost exactly the right length, but there. Okay, so what I have here are my little measures, right? I've got 4 plus 0. That'd be my 5th value, and I don't have to have a measure for 0. All right, notice these, as I'm graphing, these are going to be my sine heights. So where on the x-axis I've got pi over 2, this is how long it's going to be. It's going to be a unit 1, and so on. Okay, so I'm going to use these measures here to transfer to my graph. All right. All right, so here is my graph, and I'm going to do quad 1. Okay, and I'm starting with sine, and I'm going to make that really clear. I'm going to mark this as the sine of x. Okay, so this is a sine graph. So when x is equal to 0, let's go back over here. When x is equal to 0, y is 0. So in this case, that's actually where I'm going to sine is going to have a 0. In fact, sine will go through the 0, 0 point of the origin. All right? And I think I'm going to start with the 1, okay, here. And think about, where is sine 1? It's at pi over 2. So, and it's positive, of course. This is up is positive, down is negative. So the height of my sine graph at pi over 2 is going to be exactly that height. Okay, so I'm actually going to take a moment. I'm going to tape that down. It's going to be easy for you to see it. Okay. Okay, so there's my, this is all my quad 1 measures. Okay. And then working, I could actually work backwards, if you can tell, based on the way we had done this before, right? If you notice that pi over 3 is the next longest, right? Pi over 4, pi over 6. So I'm going to take these 3 down, all right? I knew my pi over 6 is just slightly long, so I'm going to let it hang down there a bit. And then there's my pi over 4. All right. Okay. And so what you're seeing is you're actually going to start to see the shape of the sine graph. It has a particular curve that's going to go over the top of each of my little pieces of spaghetti here. All right. Okay, so I've done quad 1. I'm going to do the same thing with quad 2. Notice in quad 2, okay, my sines are going to remain positive, but they're going to be decreasing. So you could already tell that by the time I get to pi, I'm going to be back to 0. So what I should get is a decreasing curve, the same if this one increases. Okay, so I'm going to do that one, and you could do that the same. I'm going to pause the video here right now. Okay, so here's the first half of my graph. Okay, you notice I have this nice little curve, right, that's going here, and I've gotten to pi. Now, one of the things I have done is I've taken the time to break off enough pieces of spaghetti to fill in the rest of my angles here. Okay, so you may want to do that before you go on. I'm going to point a few things out as I go to the second half. Instead of going from right to left, what I'm going to do is I'm going to think a little bit more strategically, the way we normally do with graphs, which is in terms of mins, maxes, and intercepts. It's going to make it a little bit easier to when you're starting to graph these by hand. So let's think about this. We have an intercept at 0, we have an intercept at 11, so where the zeros are, right? And we are going to have another intercept at 2 pi. That makes sense, right? Because every single one of these points, y is equal to 0. Okay, so those are going to be the intercepts. Let's think about the mins and the maxes, right? Here, this is essentially my 1, and I can actually, now that I have that length, right, okay, that is my unit, right? This is a unit circle. So this is whatever 1 is right here, right? This is 1. And so if you notice, okay, I have another little piece here that's about the same length. So if that is 1, notice going in the other direction, I can mark that as -1, right? Okay, that's down below. All right, so since sine can have both positive and negative values. So I'm just going to be thinking in terms of that's an intercept. This is a maximum of 1. Where's my minimum of 1 going to be? In other words, where's my -1 going to be? And if you notice, it's going to be at 3 pi over 2. So I'm actually going to just start by baselining, okay, and kind of landmarks. That when we start sketching these graphs by hand, this is how we're going to think about it, okay? So on this side, this graph is going to be going up like here. It's going to max out at pi over 2. Then it's going to come down to 0 at pi. Then we know we're going to have that same curvature that's going to come up here and end here. So now it's just a matter of filling in these missing pieces. So from this piece, right, I'm going to have 2 of the pieces that are the size of the pi over 3 piece. So I've got to find those, I believe. Let's see. I may have to make an adjustment here. I think I will. Okay. So, pi over 3. There it is. I found it. Okay. I made the sizes. Okay, so here are my next largest points. So I'm going to put them down here. Notice these are negative values, so they have to be on the negative side of the y-axis. Okay, I'm going to do the same thing here. Okay. All right, again, I'm seeing this piece of it. Then I'm going to move out to the quarters, right? These are the quarter pieces. So I'm looking for, there's one of mine, and looks like there's the other. Okay, so one there. I'm going to put one there. I am kind of obscuring my markings. I thought I would have probably put them up above. Okay. And then finally, the little pieces here. These are the 6, right there and there. Okay, I'm going to put them, you see that I have this symmetrical curvature. The first half before pi is all positive. That's what it's supposed to be. Second half after between pi and 2 pi is negative. All right? Okay. So now I have, this is the place where all my peaks are. For your graph, you have an option. You could simply mark these places and then sketch. Typically in a class, what we'll do is we'll just simply sketch right over the spaghetti marks, okay? So I'm going to say, well, I've got here, 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 right? So I'm going to kind of sketch over the tops of my spaghetti, okay? And then I'm going to keep going down, all right? There we go. till I get to pi. There we go. It'll look like a little roller coaster, and then we're going to be coming down. Okay, so we're going to go down to this little curvature here, and sketch it across. If you want it to look nice, you'll kind of take your time, and there we go. All right. And the reality is that this graph will continue to infinity. It'll start all up again. We could keep going this way. We could also go negative, right? But what this is we would say this is one complete period. Everything beyond this will repeat again. Everything to the left of this will repeat again. This is the complete graph, all right? So x goes in, x is my radians. What comes out is my sine value, which is the same as the y value on your graph, all right? All right, now that you've done your sine, the cosine is likely to go a lot faster. You kind of have an idea what you're doing, only this time it's just going to be shifted, okay? All right, so I'm going to label this my cosine of x graph, all right? We're going to see how does this one differ. Cosine is, of course, your x values, okay? And notice your x values are going to be the same as the y values. They're just going to be in different places, right? Okay, so let's think about 0, okay? At 0, sine was 0, but at 0, cosine is 1, okay? So I'm going to put my my piece of spaghetti, right, that represents my 1 length. I'm going to put that on the y-axis, okay? And that's also going to be a nice little convenient way of indicating my scale here, okay? So this is 1 unit of whatever, okay? This is going to be marked as 1. And just to kind of be consistent with that, I'm going to go ahead and mark my -1 down here. I'm not going to tape this, but here's my -1, right? So there's my +1 and my -1, all right? Okay. And this time again, instead of going from left to right, I'm going to think in terms of my intercepts, my 1s and 0s, right? My mins or maxes are always going to be either +1 or -1. Notice that's the largest value, right? Or the smallest value that I can get out of either cosine or sine. Neither one can be bigger than that. And of course, the minimum value is on the x scale can be a 0, right? As far as we have those zeros. So where do the zeros occur for cosine? These are my x values. Where is x going to be 0? Well, x is 0, of course, at the pi/2 point and at the 3pi/2 point. So I'm actually going to mark those really nice and clearly. I'm going to use my Sharpie here. Okay, so these are going to be the zeros. Pi/2 and 3pi/2. Okay, and then let's think about our 1s. All right, where are we going to see 1s on here? Well, that's 0. I've got 1 at pi, but it's going to be the negative version, right? So this is where it's going to be going down. So I'm going to go ahead and tape down my 1 here. Okay, my -1 to be clear, but my 1 unit going on the down direction. Okay, so hopefully you can begin to see it's going to be curving down. It's going to go through here, and then it's going to go over to the minimum here. Okay. And then it's going to hit 0 here, and at 2 pi, what is the value of cosine? What is the value of x? It's going to be 1 again, all right? So I'm going to put my last one over here. Notice that when we did sine, we only had 2 values of 1 within 0 to 2 pi, but when we're doing cosine, because we both start and end at 1, you've got 3 within that domain limitation here. Okay, so I've kind of given here's my maxes, my mins, they're marked, my intercepts are marked, so now I'm going to fill in, all right? And so what I've done is I've broken my little pieces of spaghetti ahead of time, okay, so that I've got these little pieces here, and it's kind of obvious to me that if I'm starting here, I'm going to go from biggest to little. So I'm just going to tape these down to the point where I can again see this curvature. It's a very unique curvature for sine and cosine graphs. Okay, and rather than have the video watch me do all of these. Once I flip to the negative, I'm going to let you guys do that on your own and come back to the video. There's my 0 point now. I'm going to take my 3 lengths here. From 0, I'm going to take small, then medium, then large, okay? So you can see how these are going to be taped down here, okay? So you continue this process. If you notice, you're going to go down here, then I'm going to have to put my little pieces this way, go through my 0, and go all the way up to the top, all right? All right. So now I have everything taped down, and I'm going to take a moment now to do the sketch of the graph with each of these indicating the height or the depth, if you will, of y, okay, which is, in this case, cosine. Okay, so we have this nice little curve, and again, I'm trying to make it curvy, not straight. We're not doing straight lines. Everything is curved here, right? Okay. If you did a nice job measuring, you're going to get a very nice approximation of your sine and cosine curves. And there we go. All right. Okay, pretty good there. Can fill it in a little bit more, but there you get, that's the idea. Okay. All right, so this is the cosine graph, okay? The way that a lot of people keep these kind of straight between the two is to look at cosine kind of starts like a coaster, right? A roller coaster, you start high in order to be able to have, you know, gravity to be able to pull you down. So cosine starts like a coaster up at the top, all right? So cosine starts from a maximum, and then in the middle it dips to its minimum. Whereas x, sine of x, always starts at the origin, okay? And what I hope you can notice is that there is symmetry, obviously, to these, right? That if I shift sine and cosine, okay, right? If I shift them by pi over 2, they will lie on top of each other, all right? You could actually see that when you graph these on your graphing calculators. So the reality is that cosine is really a graph of sine simply shifted over by pi over 2, okay? And that is that 90-degree rotation between the two axes. That's how all of that fits together, all right? Okay, so part of your assignment is to bring me a copy of your, bring me your graphs if you come to class, that for a grade. If you are remote, I would like you to take a photo of your graphs and send that to me. If you're not a fan of the spaghetti, some people like to take these off or even just break them so you can see all your little measures, but you can take these off. The point is to see the shape, right, and make sure that that curvature is accurate. Okay, there's one more step here. Right, we're almost done. Here's the last part, which is to sketch these graphs on your own, all right? So there is a special version of graph paper that you can print from the class website that I would like you to use. If you have not printed that, go and pause the video and go take care of that now. Okay, I'm going to go ahead and do sine on the top. Okay, so I'm going to say that this is my sine of x, and again, this is x, this is y, all right? This one will be my cosine of x, all right? Okay, so we're going to do sine first. And what we're going to do is we're going to use the graph that you just created as a reference, all right? And again, when we do these, we think in terms of the zeros and the maxes and the mins, all right? So I'm going to take that into account, that sine, okay, sine's zeros are at 0, they're at pi over 2 and 2 pi, all right? So this is the one that's going to be kind of curving like this, okay? It's going to be symmetrical to the origin, if you will. Okay, a lot like the graph of x cubed is. And remember that sine of x is an odd function, so that should fit as well. All right, I need to label where I have 1 and negative 1. What I think I'm going to do is I'm going to mark my 1 right here. You actually have a choice. Okay, but those are my maxes and my mins. And we're going to call this the parent graph here, okay? If I look at my sine graph, my max is at pi over 2. So I'm going to dot that, okay? And then my min is at 3 pi over 2. Okay, I'm going to dot that, all right? And then when we sketch these guys, we don't actually mark our pi over 6, pi over 3 values. You just simply make sure that you get a little bit better at this as time goes by, but you're going to give it this nice little curve, all right? And this does take a little bit of work and a little bit of practice to get it nicely, but we don't want straight lines, obviously, okay? So I'm going to go ahead and sketch this curve, okay? And if you notice, it is going to be increasing at a decreasing rate until it hits that maximum, okay? And then we're going to do the same thing, kind of a symmetrical curve as it hits that 0 point, okay? Then we're going to do the same thing on this point here, right? It's going to go along here, okay? And then it's going to curve up, all right? You don't want peaks at your maxes and your mins. You want smooth little curves, okay? So that is a really good rendition of a sine curve. This is from 0 to 2 pi, all right? And then, of course, this could go on forever, right? In either direction. It has no limitation on the domain, okay? We're going to start now with cosine. I'm going to mark the same points here as 1 and -1 because it's really easy to see. Okay, you have a choice kind of which way you're going. Now here again, I'm going to think about where are my maxes, my mins, and my zeros. Well, in this case, my max, min, and max, the beginning, the middle, and the end with the zeros are at pi over 2 and 3 pi over 2. Okay, so I have a max, right? I have pi over 2 as a 0. Then I have a min at pi, okay? Then I have a 0 at 3 pi over 2, and then I have another max over here, all right? Okay. And now I'm going to sketch my cosine graph. And again, I'm not going to do anything kind of weird and funky, right? It's going to be curvy, okay? And there you go. Pretty good. Doesn't have to be perfect, right? But you want to get that curvature in there. All right. There's a pretty good rendition right there. You're going to want to get to where you're very, very familiar with these two. These are the parent graphs, right? This is with the unit circle, right? We can have all kinds of translations and transformations of this. But you need to get very comfortable with the basic graphs before we can start working with those, okay? That's it for this lab, and I will see you in class.